Billions of years? Are you kidding me? Who came up with those numbers?
Numbers are not science. Numbers come from calculations, and science depends upon the changing philosophy of science. In this video, we will look at the math and the philosophies behind the numbers that give us billions of years for the most widely accepted age of the universe. Earlier this year, I completed an 11-part video series called Life After the Flood that describes the migrations of people from the mountains of Ararat into the rest of the Middle East and beyond. All dates were relative and involved periods of time rather than absolute dates. Absolute dating is complex enough that I am dedicating a separate series to it, which I have entitled Time Before Abraham. Suppose someone tells you that the Neolithic began 12,000 years ago, or that Neanderthals lived tens of thousands of years ago. When you hear that, you should ask them, do you also believe that the universe is billions of years old? Because faith in an old universe inflates the timescale for human history. Once you have billions of years for the universe, it's easy to imagine millions of years for mankind. Well, I'm skeptical about both, and I want to explain why. This video deals with the age of the universe, and part 3 will deal with the age of the Earth. The mantra of billions of years is heard everywhere, from the Smithsonian Institute to cartoons for children. It has permeated our culture, beginning with academia and extending to hot topics such as life on other planets and the extinction of life due to climate change. It's incredible how much of our thinking assumes an old universe. So if the universe is not billions of years old, then much of our culture is also wrong. But it's important for you to understand that I don't see this as a contest between young Earth and old Earth. It's not a winner-takes-all debate. Scientific skepticism is a better approach. I look at this as an engineer who associates a certain degree of error with every measurement. 500 miles plus or minus 1 millimeter is not the same as 500 miles to the nearest 500 miles. The precision and accuracy of how we measure dates in the past is what is really in question. Dates before 2000 BC cannot be calibrated with any accuracy. Some people place the cutoff date around 1500 and others at 612 BC. At some point in the past, measurements of time become uncertain. Uncertainty should also be a part of any statements we make about origins. There's a lot that we just don't know. I'm personally concerned that the media exaggerates the case for stellar evolution. Science doesn't come on that strong. I see concerns in 4 areas that I want to discuss here: the uncertainty of measurements, the formation of stars, the Big Bang Theory, and dark matter. Problems are significant enough that they should keep us from being dogmatic about the age of the universe. Look up any star and you will be given numbers for its distance and its age. You can even find a precision for the measurement. But how can we be certain about any of those numbers? Everything we know about the universe depends upon what we see from a great distance. We don't have any means of calibrating our measurements like a celestial tape measure. So how do they measure the distance to a star? Measurement starts with the closest star to us in the solar system, which is Proxima Centauri. This is the easiest star to work with. It's been measured by parallax to be about 4 light years away, or 25 trillion miles. It takes 4 years for its light to reach us. Stellar evolution theory, on the other hand, thinks it looks like it's between 5 and 6.5 billion years old. Redshift should be able to tell us how fast it's moving away from us and thus how old it is. Unfortunately, it's moving toward us rather than away from us. Redshift doesn't tell us how far away it is or how old it is. The distance to close stars is measured by parallax. Parallax is what our eyes use to judge distance. Our eyes are set a few inches apart for that purpose. Suppose you stand in the end zone of a football field, looking at a pinhead that on the opposing 38-yard line. How accurately can you determine the distance to that pinhead just by looking, without using the yard lines, of course? Well, that's what it's like to measure the distance to Proxima Centauri. Of course, astronomers take pictures when the Earth is in one position of its orbit around the Sun, and then 6 months later when it's the furthest away from that position. This gives a base of almost 200 million miles. Unfortunately, Proxima Centauri is located 250,000 times that distance, and that's the closest star. The precision of taking pictures with telescope has greatly increased, especially with the James Webb Telescope. At great distances, however, great precision of measurement does not guarantee great accuracy. There's a limit to what we can measure with parallax. Our galaxy, the Milky Way, has 100 to 400 billion stars. We don't know how many because we can't even count them. And only a fraction of them can be measured directly with parallax, up to about 30,000 light years away. There are an incredible 10 to the 23rd power stars in our universe that can't be measured with simple parallax. In fact, the first galaxy beyond our Milky Way is 2.5 million light years away. It was only at the time of Einstein and Hubble that scientists realized that stars exist beyond the Milky Way. How then do we determine the distances to most stars? Astronomers build off the parallax measurements to close stars to estimate the distances to the next closest stars. Different methods are used at different distances, since no method works at all distances. That's why it's called the extragalactic distance ladder, as shown here. The measurements of the first rung of the ladder are used to calibrate the next rung, which is then used for the following rung, and so on. The error in measuring close stars is multiplied in each subsequent level. Linking one method to the next, then, such as the Cepheid variable stars, brings its own uncertainty. Understand that all we have to work with is light, and light has its own uncertainty. For instance, light can speed up. Energy is supposed to have moved faster than the speed of light during the inflation period of the Big Bang. Another theory speaks of tired light, which means that light can slow down. We know that light bends, so a star is not always where we see it. Time is also distorted at the speed of light. They say that seeing is believing, but only when seeing things that are familiar with us, which doesn't apply to stars. We can only guess at what we're seeing in space. One strange thing that light does is that it stretches when a star is moving away from us, which is called redshift. The light coming from most stars in the Milky Way is shifted toward red, which is why we believe that the universe is expanding. And Einstein's theory of relativity was modified to reflect that. There are some things we should know about this phenomenon. First, not all stars are moving away from us. Stars within our Milky Way are moving toward us, which means that our galaxy is contracting. The closest galaxy outside the Milky Way, the Andromeda Galaxy, is also moving toward us. Some of the most distant stars in the universe, called blue outliers, are also moving toward us. Besides that, the velocity of stars is a combination of the expansion of the universe and the unique path of that star, which makes it very complicated. We can't see the proper motion or sideways motion of distant stars, so we don't know their paths. The actual paths of distant stars are unknowable. Not only are we limited by measuring techniques, by the nature of light, by inconsistencies, and by the complexity of motion, but some things are just weird. For instance, the Methuselah star was originally measured to be older than the age of the universe and is right next door to us, right here in our own Milky Way. That's weird. Then, when we look as far as we can to the edge of the universe to find early stars, they aren't there. And that's weird. We were once given the impression that matter was exploding. Now we're told that space is exploding and that stars are moving in every possible direction. It's like a room that's getting bigger and the air inside it expands with it. There's not supposed to be a center to the universe, which is weird because we're also told that the universe began as a singularity. Energy that was moving outward faster than the speed of light turned into matter. So, when did matter stop moving outward and the universe start expanding? And why? That's mind boggling. Here's something else to think about. Hubble's law relates the speed of stars to their distance. So if we divide the speed of light by the Hubble constant, you find that anything beyond 14 billion light years away is expanding faster than the speed of light. The diameter of the visible universe is 93 billion light years. So how can we see it? And how can matter move faster than the speed of light? Also, if you're seeing light from a star on the edge of the universe, that is 14 billion light years away, it's not there anymore because it's moving away at nearly the speed of light. That's where it was 14 billion years ago, which means that the universe was that big that long ago. Only the universe was only 84 million light years across at that time. So, how is that possible? Nothing is as it appears to be. Then there's cosmic microwave background radiation, which has a redshift of 1089, which means that it's moving 100 times faster than the fastest star and is 100 times farther away. The only way we could see it is if the universe is expanding faster than energy is traveling through space. Rajendra Gupta found a real problem this year. You see, the James Webb Space Telescope found extremely distant galaxies that are old and should be young. What we observe doesn't fit the model, so he is arguing for doubling the age of the universe to 26.7 billion years. What does that say for science if we reject careful measurements and tweak the formula to change the numbers just because some of the data doesn't fit? Consider the book of Job in the Bible. When Job had finished bragging about all that he had done to help other people, God asked him at least 66 questions about things that would have been impossible for him to do, such as, can you bind the chains of the Pleiades or loose the cords of Orion? Shouldn't it humble us to realize that we can't change a thing in the universe? All we can do is look at what's there. Measurements are uncertain, but stars are impossible. We were told that clouds of hydrogen collapse into stars, and we were shown pictures of stars inside gas clouds of hydrogen. But no one has ever seen hydrogen become a star, nor can they, because it takes too long. Star formation goes against what we learned in chemistry class. If you release hydrogen into a room, gas pressure causes it to expand to fill the room, not collapse. Even the cold temperatures of space do not make gas collapse. Hydrogen atoms moving out from a Big Bang would spread out, and gravitational forces would never be strong enough to bring them together. In fact, Huge quantities of hydrogen atoms must be tightly compacted by some unknown force before gravitational forces can take over. That would be against natural laws, so it would be supernatural. It would be no different from a religious miracle. So let's call it what it is, a miracle. Cosmologists can imagine, hypothetically, a situation in which a star might be able to come together from collapsing hydrogen gas. But even if it could happen, that doesn't mean it actually did. It would be the exception rather than the rule. It requires very specific conditions, which may have never existed. Even if the gas clouds could produce a star, it's unnatural for dense gas clouds of hydrogen to exist. In other words, I see every star as a miracle. So there are 10 to the 23rd miracles in the universe, and that's a lot of miracles. It takes a lot of faith to believe that natural processes can produce such magnificent designs in space. When you look at NASA photographs, you see just how complex and diverse star formations are. Why are galaxies so complex? In 1863, the gospel in the stars theory came out and has been promoted up to this day by theologians such as Bullinger. It suggests that God created the stars for signs, as the Bible says, and that one of the purposes of stars was to prophesy redemption to the earliest people. For instance, Virgo might have been the virgin birth, and Leo the lion of Judah. According to this theory, the original meanings have been lost and corrupted into astrology. Did the complexity of galaxies come by accident or for a purpose? Stars are inexplicably complex. All stars have so called heavy metals, which cannot come from hydrogen clouds collapsing into stars. Stars can't make atoms more complex than hydrogen, helium, and lithium within themselves, even over billions of years. It takes an unnatural event, such as a supernova, to press hydrogen atoms together with enough force to turn simple atoms into complex atoms, such as oxygen. Only two supernovas have been observed, in 1952 and in 1604. But that was just heavy metal stars exploding to make more heavy metals. No one has ever seen a star made of hydrogen explode to create heavy metals, because no one has ever seen a star made exclusively of hydrogen and helium. There should be an abundance of them, but even the James Webb Telescope has not lived up to its expectations. It has searched the farthest reaches of the universe to no avail. These imaginary population 3 stars are the missing links of cosmology. What we observe does not match the theory of the Big Bang. That means that there are another 10 to the 23rd miracles when we observe all the heavy metal stars. The Big Bang Theory is a story, which is meant to give us hope by explaining where we came from. It's the gospel of matter becoming increasingly more complex by random, unguided movement. Every step is miraculous. It should have been abandoned long ago, but the only alternative to secular miracles is religious miracles. In the secular seminary, theories replace theology and faith is rewarded, but the emperor has no clothes. What is the gospel of the Big Bang? Several theories came together to make the Big Bang Theory: the expansion of the universe, the theory of relativity, and quantum mechanics. Let me try to put these three parts into perspective. I already explained how Hubble observed redshift from stars, which implies an expanding universe. Then Einstein's theory of relativity produced formulas that describe gravity and space-time in terms that went beyond Isaac Newton. We can't get into our car and travel at the speed of light, but now mathematics can. And since then, science has been dealing with theoretical and unobservable conditions. The formulas were used to model what the universe would have looked like in the past. Since the universe is expanding, it would have begun as a small point called the singularity and at a definite time in the past. Unfortunately, the relativity model can only go back so far. Quantum mechanics then came along to explain how matter could have begun to evolve from its most basic state. Particle accelerators were able to break down atoms in search for the absolute simplest elements of matter, such as quarks and bosons. That led some to suppose that the universe began as energy at the highest possible temperatures. It cooled down over 380,000 years to form the first atoms and eventually people. Together, these three parts give us a model for the universe that is expanding, cooling, and becoming more complex. This implies that the universe had a beginning. Before that, matter did not exist. Something came from nothing, which can't be explained by science. Quantum mechanics is like the origin of life experiments, except that it produces even less in the laboratory. You can't take flasks of quarks and bosons and create a beaker of hydrogen. You simply can't reproduce the beginning of the universe. The Big Bang Theory has a number of problems, such as the magnetic monopoles problem, the horizon problem, and the flatness problem. But let's start by looking at fine tuning. Fine tuning says that matter as we know it should not exist. The fundamental forces such as gravity, electromagnetic forces, and strong nuclear forces must be precisely what they are, or atoms could never have been formed. The electromagnetic force constant must be within a small range of possible values. There is only one chance out of 25 that will work. 24 out of 25 possibilities would not allow for chemical bonding. Only one value out of 200 for the strong nuclear force constant would allow the existence of certain elements that are necessary for life to exist anywhere in the universe. There's only one chance in 10 to the 23rd power that gravity would allow stars and planets to hold together. Anything else would result in chaos. The cosmological constant must be very close to zero. In fact, there are dozens of properties that must be set precisely to the correct values, but there's no particular reason why they would be. Now, I can use my intelligence and try to guess the correct values. Or I could create countless universes in an attempt to find one that works. I'm not that smart or powerful. I could leave it to random chance. But that's like playing the slot machines, and the odds are against me. The only thing that makes sense is that God carefully designed the universe to be the best of all worlds. The fundamental properties are set to the correct values so that atoms can exist, stars and planets can exist, and life can exist. That's what we refer to as fine tuning. So an old Earth requires as much of a miracle as a young Earth. The horizon problem multiplies the miracle of fine tuning by the size of space. It says that it's impossible for fine tuning to have occurred in more than one part of space, and yet the same miracle happened everywhere. Matter parting from a Big Bang should not have been able to communicate with matter going in another direction. Every part had to choose its own initial properties, and yet they're all the same and all perfect. It's a miracle of miracles that fine tuning is perfect throughout the universe. In the same way that we would expect initial conditions to be different everywhere, We would also expect matter to be the opposite, that is, uniformly distributed. Instead, it's clumped together into complex stars and galaxies. Those are two impossible observations that need to be resolved by theories. In order to save the Big Bang Theory, cosmologists theorized that there was a moment in the expansion of the universe that lasted 1/quintillionth of a second when these two problems got fixed. This is called inflation, and it's supposed to have happened when the universe was about the size of a tennis ball, I think. During inflation, matter expanded faster than the speed of light, which allowed the entire universe to talk to itself and fine tune itself before slowing down. Keep in mind that the mechanics of how inflation occurred cannot be explained. The mythical force behind inflation is called the inflaton, which would have had to exist temporarily to push matter apart. The search for the inflaton particle has come up with nothing. Another part of the inflation theory is quantum fluctuations, which have been observed on a subatomic scale. It has been suggested that quantum fluctuations happen during inflation and grew to become the irregularities that we now see in our universe. On the other hand, it's still a big jump to go from random disturbances to complex galaxies. It takes faith to believe that randomness creates order on a universal scale. There is also the transition from inflation to an expanding universe, which is described by the theory of relativity. This change depends upon a debatable mathematical fudge factor called the cosmological constant, which indicates how fast the universe is expanding. The cosmological constant has been measured today, although with great contention, and it was added to Einstein's equation to make it work. It's close to zero, which is a miracle in itself. During inflation, it had to be exponentially large. Luckily, it's a fudge factor, so we can change it whenever we need to. Unfortunately, no one can explain how and why it changed. But then it's still changing because the expansion rate of the universe is speeding up, which means that the cosmological constant is increasing. We don't know why. Luckily, it's just an arbitrary number. While all this inflation stuff is assigned to the first second, recombination would have happened 380,000 years later. Photons would have cooled enough to form hydrogen atoms, which would have given off a specific light as electrons settled to a lower energy level. This was supposedly observed as cosmic microwave background radiation and heralded as proof of the Big Bang Theory. It must have been a shock when Aegis, Steinhardt, and Loeb announced 6 years ago that the Big Bang Theory is inconsistent with what we observe. First, they noted that background radiation did not have enough temperature variation. In fact, quantum fluctuations should have been so irregular that the largest ones would have consumed all the others, preventing matter from forming. They also noticed the absence of gravitational waves, which means that background radiation doesn't come from inflation after all, so it doesn't support the Big Bang. In their own words, they wrote, quote, "For the first time in more than 30 years, the simplest inflationary models, including those described in standard textbooks, are strongly disfavored by observations," end quote. Materialistic cosmologists will continue to believe and to search for answers to what they see in the stars as they try to come up with a good story. God, heaven, hell, angels, devils, miracles. Skeptics have always said, "I believe in what I can see." So why do these same people believe in what they can't see? Why do they invoke supernatural or beyond natural explanations to explain the gaps that science is unable to explain? We see things we don't understand, so we look for a cause. For instance, the expansion of the universe is happening faster and faster. We don't see anything that could cause that to happen. It's against the known laws of nature, but there has to be a cause. Maybe there's an invisible force that we can't detect that fills the universe. Let's call it dark energy, since we can't see it, even though we feel its effect. How is that not like believing in God? Maybe it is God. I already talked about the impossibility of stars existing, but what about galaxies? They shouldn't exist either. When you add up the mass of all the stars in the galaxy, there's not enough mass to keep them together. They shouldn't be there. There has to be a cause. Maybe there's an invisible force that keeps them together, but we just can't detect it. Let's call it dark matter. I believe because something has to explain the supernatural movement of matter that I see. According to mathematical calculations, the universe would only be 5% ordinary matter and 95% dark matter and dark energy. That would mean that almost everything is dark stuff that cannot be seen or detected. Do you realize what that means? To be a materialist, most of the material that you believe in can't be seen or detected. I remember when Star Wars came out in 1977. I could not fathom what was going on. We were living in a time of extreme faith in science. And then they had the audacity to make the Force the central theme of the movie. That made no sense to me. How could an unexplained force be part of a science fiction movie? I'm still not over it. I really believe in science, and I really believe in God. Maybe that's not so crazy after all. I just finished Stephen Meyer's book, Return of the God Hypothesis, which uses Bayesian analysis to evaluate the statistical probability that God is the cause of the universe. Intelligent design doesn't take a position on the age of the earth, but Meyer does come out strong in favor of the invisible God being the cause of the visible universe. Is the universe 13.8 billion years old? Well, maybe it is. If matter suddenly appeared from nothing, if it began as an infinitely dense and infinitely hot and infinitely small singularity, if it expanded exponentially fast for a fraction of a second, if quantum fluctuations occurred at just the right time during the first second to cause irregularities, if the expansion slowed down for no known reason, if free hydrogen clumped together to make gas clouds, if clouds of hydrogen became dense enough to make stars, if population 3 stars exist even though we can't find them, if supernovas can account for all the carbon, oxygen, and heavy metals that we observe in 10 to the 23rd stars, if gas clouds naturally evolved into spectacularly complex galaxies, if the cosmological constant can change from what we observe today, if dark matter exists to hold together galaxies, if dark energy exists to cause the expansion of the universe to accelerate, if the beginning happened at the absolute earliest possible times, then maybe the universe is billions of years old. You know, the expansion of the universe does not require 13.8 billion years. It only specifies that there had to be a beginning, and that it could not have been more than 13.8 billion years ago. Fine tuning means that it was a miracle whenever it happened. A recent miracle is not much harder to believe than an ancient miracle. What about the other story, the old fashioned Genesis story? Rather than being a reconstruction, it's a revelation. That is, a first hand account dictated by the God who did the creating. This unique revelation was entrusted to Israel, the only nation that has ceased to exist for almost 2,000 years and now occupies a strategic position in our world today. That revelation came to us in Hebrew, which is the only language to have become a dead language for almost 2,000 years and is now the official language of a major nation. The long journey of this revelation is supported by prophecies and miracles that are statistically significant, including the resurrection of Jesus Christ. Most of what I will be doing in this series involves analyzing the genealogies and statements in the Bible that involve chronology. Of course, Christian opinions differ. Some Christians believe the universe is billions of years old, while others say thousands. They all respect both the Bible and science. The next video in this series will compare the four major Christian groups about origins. Join me as I continue to look at the time before Abraham.